Using Stephen Hawking's A Brief History of Time, here we are going to learn some chapters, concepts in this book, A Brief History of Time, which is Stephen Hawking's best selling book. This is the book which I introduced you in earlier videos, that it is a cosmology and theoretical physics book um, which was written by the theoretical physicist, well-known theoretical physicist Stephen Hawking. And here is chapters contents of this book. You can see here our picture of the universe, space time, expanding universe, uncertainty principle, particle physics, black holes, Hawking radiation, origin and fate of the universe, arrow of time, wormhole and time travel, unification of physics, and conclusion. So now we are going to learn some um, we are going to start the chapter 1 to learn the um, cosmology from basis. So first of all, you can see here is the photo of our observable universe from using Hubble Space Telescope, which is the deepest ever optical image, was taken in January 1996. And it shows the early universe, and with some galaxies dating back to less than a billion years after the beginning of space and time, you can see here. And in the forward, he wrote about something which is all about his earlier brief history of time and other things. And here is forward to the updated edition, that means this book. And here is the chapter. One thing I would like to present, say to you in this book, is that you can see here in the forward to updated edition that Stephen Hawking, which was the greatest physicist of our time, wrote in this book that his proudest accomplishment as a physicist was my uncertainty theorem, my singularity theorems with Roger Penrose, यानी कि उनका सिंगुलैरिटी थ्योरम रॉजर पेनरोज के साथ, एंड द सो कॉल्ड हॉकिंग रेडिएशन फ्रॉम ब्लैक होल, जो वे डिस्कवर्ड किए थे कि ब्लैक होल से हॉकिंग रेडिएशन निकलता है. दैट मीन्स मोस्ट इम्पॉर्टेंट कंट्रीब्यूशन इट वॉज फॉर स्टीवन हॉकिंग. And his no boundary proposal, an attempt to unify Einstein's work with quantum mechanics. यानी कि नो बाउंड्री प्रपोजल एक ऐसा कंट्रीब्यूशन था उनका जो आइंस्टाइन की जनरल थियोरी ऑफ रिलेटिविटी को क्वांटम मैकेनिक्स के साथ यूनिफाई करने का अटेम्प्ट करता है. दैट मीन्स दीज थ्री कंट्रीब्यूशंस he mentioned here is the proudest accomplishment as a physicist for him. So this was some contributions done by Stephen Hawking. Now here is the first chapter, our picture of the universe, you can see here. And here is the starting, and you can see here is the picture which is tortoise universe. And here is, in the Hindu scripture, depicts the earth supported by 6 elephants, and while the infernal region are carried by a tortoise resting on a snake. So this was the depiction of Hindu scriptures universe, that means Hindu universe. And you can also see here, this is the one of the most important illustrations, and this is all about medieval depiction of early Greek concept of a flat earth floating on a water with the 4 elements above it. Above Aristotle, you can see here is the Aristotle's picture, and the Roman copy of a Greek original from the 4th century BC. And now here is, you can see, uh, this is starting from philosopher Aristotle on the heaven, his book on the heaven, which he published in 340 BC. And Bernard Russell's story. And you can see here Ptolemy using a quadrant to measure the elevation of the moon, 1508. Here is the Ptolemy's picture, which he used quadrant to measure the elevation of moon. And here is the geocentric model. The geocentric model, that means earth is in center and moon is and along with sun and other planets revolving around the earth in a circular path. And here is the heliocentric model of which is now called a solar system. You can see here is the in the center, here is sun and every planets are revolving around the sun. Moons are revolving around the planets. So this is the depiction. And here is the photograph of Nicholas Copernicus, famous astronomer, father of modern astronomy. And you can see here there is Kepler's theoretical model linking the planetary orbits with a arrangement of concentric geometrical solids. This is the solar system model developed by Johannes Kepler. And here is the depiction of Galileo Galilei. You can see. Here is the Harmonia Microcosmica. You can see here showing Copernicus, Ptolemy and Galileo. And here is opposite, that means here is Sir Isaac Newton's photo and his book, the masterpiece Philosophiae Naturalis Principia Mathematica, in English Mathematical Principles of Natural Philosophy, which he published in 5th of June in 1687. Now this is the depiction that the human eye can see, that light is light always travels in a straight path. Here is these things you can see. And it is, you can see here, it is a bubble like a structure in which some galaxies. This is our universe, expanding universe, discovered by Edwin Hubble. You can see here is the photograph of Edwin Hubble, photographed at the Mount Wilson Observatory in 1924. And here is his discovery that our universe is expanding, not contracting, not static, it's expanding, ever expanding. And you can see here is the photograph of Milky Way looking toward the center of galaxy in the constellation of Sagittarius. And here is the most important thing in this scenario is that the theories that could define our universe very well is given here. The general theory of relativity describes gravity as a warping of space-time by mass and energy in it. Objects trying to move on a straight line, but their path appear bent because space-time is curved. This is the explanation of general relativity. And here is quantum mechanics describe the phenomena at atomic level and subatomic level. You can see quantum mechanics here. Here is the quantum mechanics and here is the general relativity. This is the mass. You can see here is the mass which bends the fabric of space-time. This mass bends the fabric of space-time around its neighborhood. You can see. And this explanation, general theory of relativity, can explain the phenomena of large scale structure. Even our solar system and galaxies, universe as a whole can be explained through this theory of general relativity discovered by Albert Einstein 1915. And you can see here is macrosm. Macrosm means the deepest ever view of our observable universe or so more. This is the deepest ever view. This is called Hubble Deep Field HDF, taken by Hubble Space Telescope. And now you can see the second chapter starting from there, the space and time, which I will discuss in next video.